Hey everybody. Today we're going to start looking at some more ways to do some factoring, specifically looking at what we can call some special factoring or special products. And the one we're going to be looking at today specifically is what we call our difference of squares. So where this comes from is, remember, a week or so ago, a couple weeks ago, we were talking about remembering our special products, and we had these formulas that we came up with, and we said that when we were foiling or when we were multiplying together, if the things inside were opposite, meaning so your numbers were the same, but it's just the sign was different, they always multiplied out, expanded, FOILed out to the first squared minus the second squared. Our goal today now is not to do the foiling way like we've done in the past, but we can use this as a method to factor. Okay, so if we recognize that something is the first term squared and then the second number can be written as something squared, it's going to factor into this form. Okay, and the other ones we're going to talk about in our next video. So, when we're looking at factoring, we always want to be able to look for some patterns and things like that. As you guys have seen, the different hints and the different things that we can try and use to make these simpler is going to make our life easier. So if you have equations like the ones at the bottom, there's always things that we can try and do, to make them simpler, to make them easier to factor. So, we can factor out things that they have in common, or we can always multiply our stuff by a constant if we have an equation. So if it's set equal to something, hey, we can multiply everything by a number, just like we've been doing all along in algebra, in order to make our life simpler. So for example, my first one here, right? Fractions everywhere, which make it a lot more difficult. But if you recognize, everything is a denominator of 5. So if I factored out 1/5 out of everything in that equation, it's going to make it easier. So if I take the 1/5 out of the first term, all I'm left with is x squared. If I get rid of the 5th in this one, minus 3x. If I get rid of the 5th here, minus 4. And now it's a much easier equation that we know how to factor. Similarly with the next one here, okay? So I could go ahead and try and factor out a decimal, right, things like that. But what I kind of wanted to show you here, and I forgot to put my equal sign, right, is what if I were to multiply everything on both sides of this equation by 10? The reason I chose 10 is multiplying by 10 moves your decimal one spot. So 2x squared, 12x minus 32, and then 10 times 0 is still 0. So this makes it a lot easier to solve, and in fact, even from here, I could go ahead and simplify some more. I could divide everything by 2 to take out something that's common. So that's the whole idea of today. We're going to look at those special product rules to try and make things simpler, just like we did on these examples. So let's look at our first example here. Okay, so I have m squared minus 9. All right, the idea here is, okay, what we want to do is see, can I rewrite my equation as my first term squared minus my second term squared? That's what we're trying to do. So if you look at the way that this is set up, I do have m squared, so that's something squared. That one's good to go. And now, can I rewrite 9 as something squared? Well, 9 is 3 squared. Okay, so now it's in this form, my first term squared minus my second term squared, meaning I am always able to write this then as the first plus the second and the first minus the second. All right, why don't you go ahead and see if you can do the next one I have over here, x squared minus 36. Go ahead and pause your video and see if you can do this one on your own. All right, so hopefully we could recognize that we could rewrite 36 as x, or as 6 squared, okay? And then, all right, I have it in my form as something squared minus something squared. So then I write it as the first plus the second, and then in my other one, it's the first number minus the second. So x plus 6, x minus 6. Okay, so let's look at just a couple more examples here. All right. So here, again, we're going to do this the same way. I want to rewrite this as everything in my first term squared minus everything in my second term squared. Okay. Well, we can recognize that 16 would be the same as 4 squared, and 81 is 9 squared. So now my back term looks exactly like it should, but my front term needs just a little bit of work yet. So if you notice I have each of these pieces squared, I could just write this as 4x squared minus 9 squared. And now I have everything in my front term squared minus my second term squared. So this again fits into my format, 4x plus 9, and then 4x minus 9. Okay. So for our next one here, let's do that the same way. You want to rewrite this whole front term as something squared minus your second term squared. Go ahead, pause your video, give that one a shot. Alright, so hopefully we recognize that 25 is the same as 5 squared. So then I can write this as 5x squared. 100 we can break down as 10 squared. And then again it's my first plus my second. And then the other one is my first minus the second.